Imagine you discover the ability to freeze time at will. In an instant, the entire universe, planets, light, subatomic particles would halt. But how could this work within the laws of physics? Let's break down the challenges. First, consider what stopping time implies. In relativity, time and space form a four-dimensional fabric, space-time. To freeze time globally, every particle's motion would need to drop to zero simultaneously. In classical mechanics, an object's kinetic energy cannot vanish without a force or mechanism. If a speeding car is frozen mid-motion, where does its kinetic energy go? You'd need some process to absorb or suspend that energy. Otherwise, the moment you restart time, trillions of joules would explosively reappear. To keep the ability usable, we must imagine a localized time bubble around the user. Inside that bubble, time flows normally for you, while outside, everything is frozen. But this raises immediate questions of interaction. If you move your hand, you're pushing against a medium where atoms are locked in place. Solid matter behaves differently under these conditions. Crushing against frozen atoms would generate immense pressure. Unless the bubble also phases you through the frozen world, you'd be crushed or halted by the frozen molecules. Next, consider conservation laws. Energy and momentum must be conserved. In our hypothetical bubble, the user's body retains kinetic energy while everything else is paused. If you lifted a book and placed it on a table during the freeze the moment you restart time, that book suddenly has momentum it shouldn't. In a truly frozen world, no process can arbitrarily redirect energy. A realistic time-stop mechanism would require rewriting the second law of thermodynamics. Entropy can't increase or decrease without energy exchange, but freezing time halts all entropy production. The instant time resumes, entropy must catch up, likely in a violent, chaotic release. What about biological functions? Your cells rely on molecular motion, oxygen diffusion, synthesis, nerve impulses. If those molecules froze, you'd instantly die. To survive, your body would need exemption, a selective unfreeze, but the air around you, if frozen, cannot supply molecules to your lungs. You'd need an independent oxygen bubble or a fine stream of active molecules, essentially a self-contained life support within the time bubble. Let's examine photons. Light travels at 300,000 meters per second. Stopping time globally halts photons midstream. The world would be pitch black, no photons reaching your eyes, no electromagnetic interactions. If your bubble preserves light, you'd be able to see, but that means creating an artificial light system isolated from the frozen universe. Finally, consider restarting time. All frozen interactions, chemical reactions, nuclear decays, radioactive processes, would resume simultaneously. The sudden reactivation of millions of reactions would unleash bursts of heat and pressure. A paused nuclear reactor, brought to life in an instant, could melt down or explode. So, while stopping time might be viewed as the ideal superpower, in practice it would be more like a curse. Sorry about that, and